In this video, I'm going to explain how to use your calculator for solving binomial distribution problems. The binomial distribution function is going to be under distributions, and you find it by clicking on second, variables, and then you can scroll downwards to find the binomial PDF and binomial CDF. Those are options A and B. We'll begin with the PDF. The binomial PDF computes a probability at x for the discrete binomial distribution with the specified number of trials and probability of success p on each trial. X can be entered or a list of integers. The probability has to be a number between 0 and 1. The number of trials has to be a number that is greater than 0, and it has to be an integer. If you don't specify x, a list of probabilities from 0 to the number of trials is returned. The probability density function is as follows. For example, say that you're running an experiment 7 times. There's a probability of success of 35%. From those, I would like to know what's the probability that exactly 2 out of those 7 happen to be true. So again, let's say that I am running an experiment that I'm doing 7 times. Out of those 7 times, the probability of success is 35%. And I'm curious, what is the probability that exactly 2 of those times we get a success, if you will. Again, this is the TI-84 interface. If you have a TI-83, you would be asked to input the first value, comma, the second value, comma, the third value. In this case, the number of trials, comma, the probability, comma, and the number of trials that you're curious about. So you hit enter and you get a number, right? You get 0.29, which is almost 30% probability that exactly 2 of those 7 trials happen to be a success. I'm going to do the same calculation, but I'm going to leave out x. Again, if I calculate without entering the value of x, I get a list of items. And so as I click to the right, the values start scrolling. So the first value was the probability that 0 of them would be successful. The next number is the probability that 1 is successful. The probability that 2 are successful. The probability that 3 are successful out of the 7 trials. And so on, all the way up to 7. Right? What's the probability that we get 7 successes out of 7 trials? And you can see that the probability starts going down. It starts becoming very, very small. As you can see here, 6.4 times 10 to the negative 4. So very close to 0. Now, the next example will be the binomial CDF. The binomial CDF computes a cumulative probability at x for the discrete binomial distribution with the specified number of trials and probability of successes, p, on each trial. X can be a real number or a list of real numbers. The probability of p has to be a number between 0 and 1. The number of trials has to be an integer that is greater than 0. Again, if you don't specify x, then the output will be a list of cumulative probabilities. And the cumulative is the probability all the way up to a certain specific value. So let's try that. go to distributions, second bars, and we're going to go to the B option, which is the Binomial CDF. Again, what is the probability that out of 7 trials with, for example, a probability of 35%, up to whatever number is a success. So I'm going to do it without putting X. And what happens is that it goes adding up as you increase. So what's the probability that at most 0 are a success? What's the probability that at most 1 is a success? So this number is the sum of itself plus the previous one. As you go up, this number is the probability of 2 successes, or 1 or 0. So 0.53 is the sum of the probability of itself plus the one before plus the one before. And you keep going up in terms of probability, because you're saying, what's the probability that up to, well, all the way up to 7, right? That's why this number is a 1, right? What's the probability that from those 7 trials, either all 7 of them are successful, 6 of them, 5, 4, 3, 2, 1, or 0, right? That's why it's cumulative, because it adds up all the way up to the number of trials.